So now that we've reminded ourselves that a phase angle moves our graph backwards or forwards, we're now going to look at how we apply that to an equation. So, as with all equations, you are aiming to start off by getting to the line tan x, sin x or cos x is equal to something. That is when you can use your CAS diagram, and that is when you can start finding your answers. So for this first example, we are going to have that tan x plus 30 is equal to 4/5. At that point there, we can use our CAS diagram. So tan is positive 4/5. So we're ticking where tan is positive, and it's positive in A and in T. And we can now start to solve it. So x plus 30 has to stay exactly where it is. We're going to do tan inverse of 4/5, or 4 divided by 5. X plus 30 is equal to, so a quick check, the restriction is between 0 and 360, so we are working in degrees, so I can just use my calculator in degrees for this, and I get 38.66 if I round to 2 decimal places. That is your calculator answer. We also have the T quadrant ticked, so remember that means you're going to have to do 180 plus your calculator answer. That means that x plus 30 is equal to 38.66 and 218.66. Now, remember on your phase shift graph, if you have an x plus something, your graph's moving backwards, it's moving back to the left. If you have an x minus something, it's moving forward, it's moving further along to the right. So this is why it's counterintuitive, or where it'll maybe make a little bit more sense to you. So if in this example we've got x plus 30 equals 38.66, x must be equal to 8.66. We're taking 30 away, and that's how your graph ends up moving backwards, even though we're adding 30 to it. So our second answer is going to be 188.66. Both of these lie between 0 and 360. So that's my two answers for that one. So moving on to this next one, straight away this one's a lot more complicated. So not only is it talking about radians, but it also has this 2x that I mentioned a few examples ago. So this time we are going to take account of that 2x. That will become important towards the end of the question, and this is quite a nice example for you to understand why. So at this point, maybe your teacher will take you back to the previous example if you hadn't completed it fully. You might even find that you're missing this example out in class, and you're going to come back to it after you've covered everything to do with the 2x's. But for just now, I will work this one through exactly as it should be. So, remember your first step is to always get sin x, tan x or cos x on their own. So we're going to have sin 2x plus pi over 4. Remember, pi over 4 is 90 degrees, and that is equal to a half. Once you've got sin, cos or tan by themselves, you can use your CAS diagram. So in this case, sin is equal to positive a half. So we're ticking A and S where sin is positive. Then to get this 2x plus pi over 4 on its own, we're taking sin inverse of a half. So sin inverse of a half is equal to 30 degrees. So from your exact values, we know that it's 30. So if you were working on angles, you would have to change that into radians. Remember, you could keep it as degrees right up until your final answer and then change it. But for safety, I'm just going to keep going through with radians. So to change 30 into radians, we times it by pi over 180. I can cancel my zeros out. 3 fits into 3 1 full time, 3 fits into 18 6 full times. So that simplifies to pi over 6. So over here, we've got pi over 6. That gives us our calculator answer, our first quadrant answer. We then need to do pi, take away pi over 6 to find the answer in the sin quadrant. So remember, that's 180 minus your calculator answer. That means that 2x plus pi over 4 is equal to pi over 6, 5 pi over 6. Okay, from there you need to start manipulating it to get x on its own. So first thing I'm going to do is take away pi over 4 from both my answers. Now this is something that you could do a little bit of extra working for. So if you wanted to at the side, you could do pi over 6 minus pi over 4. So remember, to subtract fractions you need to have a common denominator. I'm going to use 12 for this one. So to change that 6 into a 12, I would times by 2. So that means I've got 2 pi on the top. To change the 4 into a 12, I'm going to times by 3. So that's going to give me 3 pi over 12. 2 pi take away 3 pi gives me negative pi over 12. So my first answer for 2x is negative pi over 12. Using a similar strategy, you would then work out that your next answer is 7 pi over 12. Okay, so this is where this 2x comes into play. So what that 2x is telling you is that rather than having a graph that's got one repetition, so normally your graph would look something like that. It would start at 0 and it would end at 360. What we're being told by that 2x is that actually our graph ends over here at 360. That means our graph has now got 2 repetitions. So if you think about this half that we're looking at, half would happen up here. So when you follow that along, you'll now find that you actually have 4 points. So we've got our 2 original points that we would be finding, plus we've got these 2 extra points that we would be finding. So if you have a graph of 2x, you actually have 4 solutions potentially. If you had the graph of 3x, you would potentially have 6 solutions. So the more the graph repeats, the more solutions you would have. However, with this graph, there's a lot more happening to it. So actually, this graph has also been moved back by pi over 4. So it's been moved back by 45 degrees. And I know that because it's got plus pi over 4. So it's actually moved back that way, 45 degrees. And that is why we've ended up with this negative down here, because this value has actually moved right back past the y-axis. That's why that's important to us. That may potentially also mean that we've had one of these points coming into play. So because our restriction on our graph is pi, that means that our graph is actually ending at 108 degrees. So our graph is ending here. So when we've pulled that back, this point here that we're interested in has also been pulled back. So that point there now lies between this 0 and pi. It lies between 0 and 180. So we have to compensate for that. Now we know that our graphs are cyclical. They repeat themselves every 360 degrees. So that means that that negative pi over 12 repeats itself further along the graph. And to find that, we are going to have to add on 360 degrees. So when we do that, we end up with 23 pi over 12. So we had negative pi over 12. I'll put some working over here. We had negative pi over 12. We need to add on 360 degrees. So we are adding on 2 pi. 2 pi is going to be the same as 24 pi over 12 because we need that common denominator. And negative pi plus 24 pi gives us 23 pi over 12. So that's where that value is coming from. And again, it all comes from the fact that your graph's been shifted and we've got this restriction. So this is quite a complicated example. If you have ever used Desmos, Desmos would be a great place for you to actually see this and how it works and to make small changes. You could ask your teacher about it if they've not already shown you it. But this is something, like I've said a few times, that we will come back to. For just now, I'm going to keep going with this example. So that negative pi over 12 is out with our range, so we can forget all about that. We don't have to have that as an answer anymore. We are still trying to get our x value. So if we've got 2x equals 7 pi over 12, x must be equal to 7 pi over 24. So dividing it by 2, which means times in the bottom by 2, and we've got 23 pi over 24. Both of them lie between 0 and pi. Both of them are positive values within our range, so that is our final answer.